When investing in a piece of supply chain software, there is the expectation it will last a company decades rather than just years. However, from the perspective of the vendors, the rapidly changing tech landscape means just maintaining this is no mean feat. As such, today we're going to discuss about maintainability and why it's such a challenge, and also understand how it can be impacted by good design. So Janice, it's an intriguing topic today, kind of maintainability. It's something that you'd normally think wouldn't be associated with software. Software doesn't really degrade. So what's the idea?
Well, actually, software does degrade, and yes, it's not like mechanical degradation. You know, there is not like tear and wear where you just after use, things becomes physically fragile to the point they break down. Software, it's not the same thing, but things do fall apart over time, and that's something that is maybe, I would say, very surprising, because some of the largest and most successful software companies, let's say Microsoft, have been precisely incredibly successful because they had an insane commitment to the long-term survival of their products. I mean, it's literally a testament to the success of Microsoft that you can, at present time, in 2020, you can take a Microsoft Word document that was edited in 95 and open it, and you can still print it. So it's incredible, but it's also what most, I would say, I believe people fail to realize, that Microsoft was fairly unique in this regard, having this mindset of long-term commitment to their products. If you were to try any of their competitor, and nowadays people don't even remember that Microsoft Word, Microsoft Excel had plenty of competitors, none of it would actually work. So let's go down to the path that software degrades, and it mostly degrades due to, I would say, entropy, to the fact that this is a forever changing landscape. The hardware is changing. Software is, a very composite product at its core. You have to run anything, you're typically involving dozens of parts provided by dozens of companies. And those things are not necessarily very well maintained over time. And when there is something that changes, there is no clear, reason why would all the other parts remain completely compatible and correctly integrated with a part that has just changed.
Yeah, I mean, like the tech landscape is one that's really changing and changes very kind of rapidly. So what is it that Microsoft kind of did well? Why is it that they kind of could impact upon the longevity of kind of their software?
I mean, at the core, they did really care. And they made insane investments for that. I mean, a lot of people complain that let's say Microsoft Windows is so bloated. That you have so many things that if you go for Linux operating system, it's so much leaner and better organized and more sensical overall. True, absolutely true. But try to run anything on a program that was written for I would say a Linux 25 years ago, it will not run. The games that I purchased, as a teenager back in the 90s for Windows 95 still run nowadays. So I believe that this illustrates that you can do things right with, I would say, an insane level of commitment. And if you read the Microsoft blogs on what they are doing, to ensure this maintainability, I would say they go to insane length, literally. Now, for supply chain software, you cannot expect the same degree of commitment just because the market is not as large, and you simply don't have companies that go into such extensive length to do that. Plus, you have another problem, which is the supply chain software are also very, very complex because it's typically distributed, because there is many moving parts. So that makes maintainability all the more complicated. And now the question is, why do you have any change at all? And why can't you just freeze a piece of software and stay with it forever? And the answer is, well, first, the computing hardware itself is changing. So you can't just say this thing will run forever. I mean, yes, you can now use virtualization to mitigate most of those problems, although virtualization is frequently, a not quite completely perfect emulation of the I would say hardware that you used to have. So it can help, but then it's not just the hardware to do the compute. It's also the fact that, for example, the very way you consume. So, for example, screens have a lot more pixels nowadays. You can have touch screens. You have plenty of things that don't exactly behave like the systems, the old systems. Sometimes you have even like weird systems if you look at very ancient systems where you have keyboard keys that are just gone. If the software was designed for a certain key, I mean, maybe it was obvious at a point of time, but now that the key is gone or that the setup of the keyboard is different, it's much less intuitive. And then that's just one part of the problem that is evolving relatively slowly, but then you have all the security issues. I mean, most of the software that has been produced historically was absolutely not designed for all the sort of threats, modern threat that we have nowadays. So that puts an immense pressure to basically change tons of things in many software components.
So people always kind of want to be kind of using the latest tech when they're in their kind of workplaces. So would you say that's more of kind of a dominant issue, or is it more kind of the security side of things and the fact that it wouldn't be safe to use these pieces of software?
So first, maintainability, I think it's a sort of issue where supply chain managers are mostly unaware of it, mostly. And when they are aware of it, they only see the problem through an angle which I believe to be exceedingly weak, which is whether the vendor will still be present or not. And my proposition is maintainability has nothing to do with the survival of the vendor. Yes, having a vendor that is still alive is kind of a plus, kind of, but it's not even that much of a plus, because let's face it, I mean, many vendors have a massive perverse incentive to have something that is absolutely not maintainable. How are they going to sell the next version otherwise? If we go back to why I would say that usually this problem is even absent, is that you're not looking at the problem from the right way. You have to think that, imagine, a piece of software, a complex piece of software like an enterprise supply chain system. Imagine, I would say, a system that had, millions of moving parts, literally millions. And you had dozens of companies who were tweaking at any single point of time, some of those parts for a huge variety of reasons. Sometimes you want to be compatible with new hardware. So when you do that, you might actually create accidental incompatibilities with some ancient hardware. You might actually create you want to be compatible with a new operating system because, for example, Linux keeps changing, Windows keep changing. So you want to basically be compatible with the latest. But by introducing some compatibility with the latest system, you might actually accidentally introduce some incompatibility to the ancient system. And again, just to give you the sort of I would say the scale of the task, just I was reading, on the Microsoft publication that at a point, Microsoft was ensuring the compatibility with over 1 million printers. Just think of it, 1 million printers with different drivers and instruction set, different hardware, etc. This is how much engineering effort do you need to ensure compatibility with 1 million devices? This is borderline insane. And then you always have people say, Windows is such a crap. I've just plugged my 17 years old printer that was the version that was the Epson 7.1.6.B, Slovakian edition. And guess what? Microsoft is not, 100% compatible with this device, which is obviously such a flagship reference. But joke aside, you have this massive, going back to supply chain, you have this massive piece of software. You have tons of moving parts, a database you rely on. is constantly upgraded. The network layers you're using is constantly upgraded. The web servers that you're using is constantly upgraded. You have so many moving parts. And so by default, what you have is, unless you I would say, engineer specifically your software to be highly maintainable, it's not going to be maintainable.
But the thing about kind of supply chain is it's very much kind of a longer game that people are playing. And it's not only that vendor that we should be thinking about is, are they going to stick around? But it's also all the people that vendor kind of interfaces with. So how much confidence can you actually have that these other companies will still be there in the future as well?
So again, the fact that companies will be there or not, mostly don't care. Mostly. This is not the proper way to think about that. Again, if you have vendors that are still there, but that have a vivid incentive to basically make the thing unmaintainable to sell more, have you actually, made any progress toward maintainability, or have you actually run in the opposite direction? So you need to analyze the situation through the incentives that the people have. And that's another thing, is that mostly, that's my belief, is that maintainability is pretty much a matter of design. But what kind of design exactly are we talking about? And here, I believe that it's mostly about the conservation of the technological mass. You see, if you want to have a product that makes very, very cool demos, what do you need? You need the latest and coolest data visualization library. You need the latest and coolest UX, library. You need, if you want to have fancy real-time analytics, you need to have the latest and coolest, subsystem to do that, etc., etc. So your incentives to win demos, to win clients through demos, is to have, I would say, a wow effect. And for example, a lot of my clients were telling me, our ERP screens just looks like, text terminals, just black and white, pure text. And they were saying, we really have to do something. And I challenge that, I challenge that, because when I'm looking at those terminals, that looks like, we are back in the early 80s or late 70s. And I see people using those terminals, and it's like super fast, incredibly responsive. The screen is ultra minimalistic. There is like 5 commands that you have to know by heart, but this is it. No distraction whatsoever. It's like purely utilitarian, and people have, I would say, an insane productivity with it. Yes, it looks like crap, but if it's what it, and it's, why is it highly maintainable? Because you have literally no dependency whatsoever, and certainly no web dependency with web browsers that keep changing. So, and again, if you look at, both, I would say, the oldest part of supply chain and the most advanced part of high-frequency trading in finance, you would see that the user interfaces are kind of similar, because if you look at those quantitative traders that are using super advanced systems, you look at their user interfaces and it's text terminal all over again, and you would think, it's kind of bizarre. Those people are absolutely state of the art, and their UI looks completely crap, completely the opposite of what you would say you would think of, I would say, the Hollywood movies of user interfaces.
It seems kind of frustrating, because kind of everybody wants to be using those latest technologies. So is what you're saying that basically having a product that's very maintainable means that ultimately you can't be very much at kind of the cutting edge?
I mean, again, if you're cutting edge in terms of maintainability, why not? I'm not saying that we haven't made progress in this area as well. We did. It's just that it doesn't trigger any kind of wow effect. When you have very, very clean versioning strategies in place, when the components that you pick have some very interesting philosophies, such as, for example, are you picking components, software components, for where the philosophy is we are done with the design of this piece of software, and now it's explicitly all about maintainability. There are some components that we use at Lokad that are open source components that have exactly this philosophy. They say they are literally, their manifesto is, this problem has been studied for the last 20 years. We have converged to what we feel is the best trade-off in terms of design, and we are done. And now all we will ever do with this component is proper maintenance, just to ensure that, in terms of security, there is nothing, seriously wrong, that in terms of compatibilities, there is no accidental problems, and we will not keep reinventing ourselves. So you'd say, it's disappointing, it's the opposite of innovation. But again, do you need to have innovation on every layer of your software? Are you going to keep reinventing the way you're dealing with your calendar? Are you going to keep reinventing the way you're storing passwords, for example, unless there is some cryptographic attacks that have been invented and that requires you to upgrade? So literally, you want to choose things where you already have stability. And it's interesting, software engineering is not a new discipline. We have now, about 50 years worth of history to learn from. It's a lot. And but the question is that, again, because clients or prospects, they don't, most of them, and that would be my message for the audience, they don't pay attention to that. So they would ask the naive question as, are you going to be still around, versus what is your incentive to make really sure that your software is maintainable, as opposed to do the opposite, so that I will buy your next license.
So what should that supply chain practitioner be kind of looking out for then? What are kind of the clues that there's a piece of software that's very maintainable compared to a piece of software that's maybe just a bit old-fashioned, and actually people are just kind of being maybe lazy and not updating it?
First, I would say just look at the incentives, because it's not so technical. So for example, if you're buying a license or something where the vendor is basically charging hefty implementation fees, that means that the revenues of the vendor are concentrated at the beginning of the project. And then what happens afterward is just less of the same. So it's literally a downward trend, which means that the vendor has a structural incentive to basically have those hefty implementation fees be repeated as frequently as possible. That's, one way to look at it. Look at Lokad, on the other hand, shameless plug, we charge a monthly fee, no commitment, and we typically lose money on the first, we basically break even after 2 years, which means that, and then afterwards, the maintainability is basically, it's a flat fee. So the cost in terms of maintainability, it's basically eating the margin of Lokad. So you see, when I positioned Lokad, I decided that I want to make sure that we have skin in the game, that we are paying the price of having unmaintainable software. And thus, that gives us, a massive incentive to make, something maintainable, just because there is no money to be made, and quite the opposite, there is money to be lost for us, the vendor, if it's not maintainable. So that would be just the incentive. So obviously, monthly subscription where you ensure that basically your vendor is losing money at the beginning is a very good, healthy start. That frame the problem so that it's going to be kind of maintainable. And then you want to make sure that obviously the vendor is dealing with the maintenance of their own software, which is basically what SaaS, software as a service, is about. If it's unmaintainable, I mean, first and foremost, this is a problem of the vendor, not your problem, as a company operating the supply chain software. Then there are other things like the technological mass. When I see, slides, PowerPoints of my competitors, and they show, their all the pieces that are in their solution, and you can see that they have 20, super sophisticated, super complex subcomponents. They have so many tools. They have nowadays they would have TensorFlow plus Apache Spark plus Kafka plus MongoDB plus React plus Redux plus Hadoop plus etc., PyTorch, and oh la la la. You have so many things. You have literally, whoa, it takes like a massive slide, and people say, look, we are like state of the art of the state of the art, and we have everything and even more. This is not going to fly. I mean, this should be a red flag where when you look at those sort of things, your first reaction should be, this is going to be such a nightmare to maintain, because every single one of those components is going to have its own life cycle. And even if at a point of time in the past, there was like an alignment of the planets where all those components by chance were working together at this point of time in the past, there is nothing that guarantees that it will be the case, let's say 3 to 5 years down the road.
Okay, have you got kind of any examples you could perhaps maybe share with us here? I mean, where is it that you've come across pieces of software that have been unmaintainable, and kind of what are the issues that that's kind of led to?
I mean, at the symptom level, you could see that when people basically give up on, and usually people say, oh, supply chains are run through Microsoft Excels and spreadsheets. Why is that? Well, people have, I mean, it's not like, especially large companies, it's not like they haven't purchased a supply chain system. They have. Usually during the last few decades, they have even purchased like 3 of them. And, but people try to tweak, the solution has complex forecasting modules, complex replenishment modules, complex, assortment optimization modules, complex promotion management modules. I mean, all of that is part of the systems. But there was like an initial implementation. It was kind of okay initially because the vendor was actually pushing a lot of efforts, and then and then they were trying to keep operating the system, but there was a glitch, and then the second glitch, and then third glitch, and then 1 year down the road there is like over 100 glitches that are active on the system, and at some point every single day that passes you have a new additional small problem that doesn't get fixed. And it requires even longer, workarounds to kind of cope with all those defects. And so at a point of time, people just give up. So what do? They just give up on the features entirely, and they fall back with their Excel spreadsheet, and they say, well, I'm going to pick my battles, and my only battle is going to be, I need to export the data to an Excel spreadsheet. And that's going to be the only feature that I want to be maintained. And I surrender my hopes of making anything work but the export toward Excel spreadsheets, and then I fall back to my Excel spreadsheets. And that's a story that I've seen in, I don't know, dozens of companies. And it's literally, the symptoms of a solution that has gone completely unmaintainable.
Okay, if we start sort of concluding today then, is kind of the core message that kind of all that glitters is not really gold, and we should maybe be a little bit wary of those companies that have got all those flash kind of UI interfaces, because there may be issues of maintainability in the future?
Yeah, I mean, again, I'm not saying that having like a garbage user interface is a solution either. If you're coming with a vendor where their solution looks like it's back from the 90s, well, the chances are that it's so unmaintainable already that the vendor did not even manage to upgrade their UI. So again, there is no hard rule, but I would say my advice is you need to challenge, even if it's like an internal development, so in-house software, you really need to challenge people who are in charge of the development of what is your plan for maintainability. What are the key design decisions that you are making now to ensure that your software will be maintainable? And again, if people don't have a very precise vision of how, I would say, the design decision that they are making is shaping, the future maintainability of the software, then as a rule of thumb, you can assess that the software will be unmaintainable, because it's a default, status of products that are engineered in this industry without carefully paying attention to maintainability. It's unmaintainable by default.
Okay, we'll wrap it up there. So that's everything for this week. Thanks for tuning in, and we'll see you again in the next episode. Thanks for watching.